They built things that should not have existed. A machine that could predict the motion of the heavens more than 2,000 years before modern computers. A concrete that grows stronger inside seawater while our own buildings crack and decay in a century. A blade so sharp it could split silk in midair, yet so advanced that modern laboratories still argue over how it was truly made. These are not myths. They are not fantasy. They are not stories carved out of superstition and passed around the internet for entertainment. They are physical objects. Metal, stone, glass, pigment, mechanisms, materials you can see in museums, scan in laboratories, and place under a microscope. And that is exactly what makes them so unsettling. Because once you strip away the legends, one fact remains. Ancient civilizations developed technologies so precise, so durable, and so strangely advanced that even now, with supercomputers, electron microscopy, and industrial engineering, we still cannot fully explain how they achieved them. Today, we are looking at 6 of them. 6 technologies, 6 civilizations, thousands of years apart. And every single one leaves behind the same uncomfortable question. How much knowledge has humanity lost? The first mystery begins underwater. Not in a temple, not in a tomb, but in the open sea, where modern concrete slowly dies. Walk along almost any modern coastline, and you will see the same thing. Cracks, salt damage, corrosion. Steel reinforcement swelling from the inside. Concrete is strong when it is young, but seawater is relentless. It seeps into every weakness, attacks every flaw, and turns even massive structures brittle over time. Engineers know this. That is why marine construction is expensive, temporary, and in constant need of repair. And yet the Romans built harbors, breakwaters, piers, and seawalls that have stood in harsh salt water for nearly 2,000 years. Not decades, not a few centuries, 2,000 years. At places like Portus Cosanis and the Bay of Naples, Roman marine concrete still survives where modern materials would have crumbled long ago. Waves hit it, salt penetrates it, time punishes it. And somehow, instead of falling apart, the material appears to become stronger. That should not happen. Modern concrete is designed to resist the sea. Roman concrete seems to collaborate with it. Scientists studying these ancient structures found something extraordinary. Roman builders mixed volcanic ash with lime and chunks of volcanic rock. When seawater entered the concrete, it triggered chemical reactions that slowly formed rare interlocking minerals inside the cracks. In other words, the ocean was not just eroding the structure, it was helping repair it from within. Think about that for a second. A civilization without modern chemistry textbooks, without electric mixers, without reinforced steel, created a marine building material that, in certain conditions, outperforms what we pour today. And the deeper researchers look, the stranger it gets. Because Roman concrete was not one universal recipe. Different sites used different volcanic materials, different ratios, different methods. This was not crude guesswork. It was controlled knowledge. Practical, repeatable, engineered. Some researchers believe we are only beginning to understand why it worked so well. Others admit something even more surprising. We still do not know how to reproduce its full long-term behavior with certainty. The Romans did not just build for their own lifetime. They built for millennia. And if their concrete could survive the sea itself, then what you are about to see next is even harder to dismiss. Because the second technology was not built to resist nature. It was built to predict the universe. If this fascinates you, if it makes your mind race with questions about what humanity has truly lost, then don't just watch, be part of the journey. Subscribe now to uncover the secrets that history tried to hide, and drop a comment with the mystery that shocks you the most. Your curiosity fuels this exploration, and every voice matters. In 1901, sponge divers working off the coast of a small Greek island found something they were never supposed to find. At first, it looked like a shipwreck filled with statues, pottery, and broken bronze, the kind of discovery archaeologists dream about. But among the treasures was a corroded lump of metal so ugly, so damaged, and so easy to ignore that it might have been dismissed as scrap. It was not scrap. Inside that green, crusted mass were Gear's dozens of team, tiny bronze teeth, cut with astonishing precision, packed into a mechanism so complex that when scientists finally understood what they were looking at, it forced them to ask a question no one wanted to ask. What was a machine like this doing in the ancient world? This object is now known as the Antikythera mechanism. It dates back more than 2,000 years, and calling it a device almost sounds too weak, because in function, this thing was something far more disturbing. It was a computer, not electronic, of course, not digital, but computational. Turn a handle and a hidden system of interlocking gears could model the movements of the sun, the moon, and likely the known planets. It could predict eclipses, track lunar cycles, follow calendars, and possibly even show astronomical events years in advance. Let that sink in. This was not a toy, not a decorative artifact, not a symbolic object made to impress a king. It was an analog machine, built to calculate the sky. The mechanism contains gear ratios so sophisticated that for decades historians refused to believe it could be authentic. Some researchers compared its complexity to medieval cathedral clocks. The problem with that comparison is brutal. The first machines of comparable sophistication do not appear again in Europe for more than 1,000 years. 1,000-year gap. It is as if one chapter of technological history was written, then ripped out, burned, and forgotten. Modern imaging techniques revealed inscriptions on the device, instruction-like texts, scale markings, and design choices that suggest this was not an isolated miracle built by accident. It belonged to a tradition of knowledge, a tradition advanced enough to miniaturize cosmic cycles into bronze gears and place them inside a portable box. And that may be the most chilling part of all. Because if they could build this, what else could they build? You do not create a machine like the Antikythera mechanism as your first attempt. Precision gearing at this level requires mathematics, metalworking, design planning, error correction, and generations of accumulated craft. This machine did not emerge from ignorance. It emerged from mastery. Some historians connect it to the intellectual world of Archimedes and Hellenistic engineering. That may be true, but even if we place it in that tradition, the mystery does not disappear. It deepens, because we still do not know how widespread this technology was. We do not know how many similar devices existed. We do not know who made it, who used it, or how much knowledge vanished with the civilization that produced it. All we have is one survivor, one damaged machine pulled from the sea. A message from an ancient mind so advanced that even now, it feels out of place in its own century. But if the Greeks built a machine to predict the heavens, the next civilization created something even more intimate. Not a device that measured time, a material that mastered it. Metal so legendary that even broken blades still feel like an accusation. For centuries, warriors spoke about certain blades, the way people speak about miracles. They said these swords could slice through armor, hold an edge like no other weapon on earth, and bend without breaking. Some claimed they could cut a silk scarf in midair. Others swore they could split a falling hair. Legends grow around weapons very easily, but Damascus steel is dangerous, because beneath the legend, there is a real mystery. The blades existed, the patterns were real, and the technology behind them was so advanced that it was eventually lost. True Damascus blades were famous for their flowing surface patterns, like ripples in dark water. But that pattern was not mere decoration. It was the visible sign of an internal structure that gave the steel extraordinary properties. Hardness and flexibility, sharpness and resilience, all balanced in a way that blacksmiths still admire. That balance should have been nearly impossible. Make steel too hard, and it becomes brittle. Make it too soft, and it loses its edge. Yet these blades seemed to do both. The mystery begins with the material known as wood steel, produced in India and traded across the ancient world. Somewhere along the chain of knowledge, from smelting to forging to temperature control to cooling, learned how to transform that metal into something extraordinary. Not just useful, elite, almost mythical. And then the method disappeared. That is the part that should bother you most. This was not a natural resource vanishing from the earth. This was a manufacturing process. A sequence of decisions, heat levels, timing, impurities, hammering technique, carbon distribution. Knowledge passed from hand to hand until At some point, the chain broke. Modern metallurgists have studied surviving blades under microscopes and found structures so fine and controlled that the debate still continues. Some researchers have reported carbon nanotube-like formations and cementite nanowires in the steel. Others argue over exactly how those structures formed and whether they fully explain the legendary performance of the blades. But on the central point, there is no dispute. The original method is gone. We can make excellent steel today, better in many practical ways. Yes, but that is not the issue. The issue is that a pre-modern craft tradition achieved a signature microstructure and performance profile that modern science had to reverse engineer centuries later. Imagine that, an ancient blacksmith, standing before a furnace, watching color and flame with the naked eye, controlling chemistry through experience rather than equations, and producing a material so refined that laboratories in the modern age still debate its secrets. This is not primitive technology. This is specialized, high-value, high-skill manufacturing. The kind of knowledge economies are built on, and maybe that is why Damascus steel captivates people even now. Because it proves that progress is not guaranteed. Knowledge can rise, knowledge can flourish, and knowledge can vanish so completely that all that remains is the artifact and the envy it inspires. A lost formula, a lost process, a lost mastery of matter itself. But metal is not the only thing the ancient world learned to control. Because the next technology did something even stranger. It created a color so durable, so chemically stable, and so resistant to time that after 1,000 years of heat, humidity, rain, and ruin, it still refuses to die. There are colors in ancient ruins that should have disappeared long ago. Rain should have taken them. Sunlight should have burned them away. Humidity should have broken them down molecule by molecule until nothing remained except dust and memory. But in the lands of the ancient Maya, one color survived when almost everything else faded. Blue. Not a weak stain, not a ghost of pigment. Living blue. Brilliant. Stable. Defiant. Archaeologists found it on murals, pottery, sculptures, ceremonial objects, and sacred spaces across Mesoamerica. Centuries passed, cities fell, forests swallowed stone. Storms came and went, and still this pigment endured. Today, it is known as Maya blue. And for a long time, no one understood how it was made. That is what makes it so extraordinary. The Maya did not have industrial labs, synthetic polymers, or modern chemical instruments, but somehow, they combined natural materials in a way that produced one of the most durable pigments in human history. The recipe sounds deceptively simple. Indigo dye from plants, a particular clay mineral, often palygorskite. Heat. Time. Skill. But simple ingredients do not guarantee simple results. Anyone can mix materials together. That does not mean they will bond correctly. That does not mean the color will survive acid, humidity, biological decay, and centuries of exposure. Maya, blue, div. Scientists who studied it discovered that its stability comes from an unusual interaction between organic dye molecules and the microscopic channels inside the clay. Under the right conditions, the indigo becomes locked into the mineral structure in a way that protects it from breakdown. The result is a hybrid material, part organic, part mineral, almost unnaturally resilient. But there is still debate over exactly how consistent the process was, how the heating was controlled, and how Maya artisans discovered the conditions needed to create such a stable compound in the first place. Because this was not a lucky accident. You do not accidentally invent one of the most chemically resistant pigments of the ancient world and then use it across ritual art, architecture, and sacred practice. This was repeatable knowledge, cultural knowledge, technical knowledge. And there's a darker detail here that many people never forget once they hear it. Maya blue was linked not only to beauty, but to ritual. In some sacrificial ceremonies, offerings were painted in this same luminous blue before being given to the gods. That means the pigment lived in two worlds at once. Art and death, decoration and devotion, chemistry and belief. A color strong enough to survive the jungle, and and sacred enough to accompany a human being to the edge of eternity. That is not just pigment. That is technology embedded in religion, memory, and power. Even now, Maya Blue feels modern in the strangest possible way. It is nanostructural, chemically elegant, environmentally durable, the kind of material science we like to imagine belongs to advanced laboratories. And yet it was made centuries ago by hands that history once called primitive. But if a civilization could engineer a color that outlived empires, the next object is even harder to explain, because it does not merely survive light. It reacts to Italiano. It changes before your eyes. And for one impossible moment, a Roman cup seems less like glass and more like technology wearing the mask of art. In a museum in London sits a Roman cup that behaves like a trick. Viewed in reflected light, it appears green, but place a light source behind it, and the same cup turns deep, glowing red. Not painted red, not stained red. Transformed, this object is called the Lycurgus cup. It was made in the 4th century Roman world, and for a long time, people admired it mainly for its craftsmanship. The carving is astonishing. The survival of the glass is rare. The mythological scene wrapped around it is beautiful, but beauty is not the real mystery. The real mystery is why the glass changes color at all. When scientists studied the cup in modern times, they discovered something remarkable. The glass contains tiny particles of gold and silver dispersed through the material at a scale so small that they interact with light in different ways depending on how that light passes through it. In plain English, Roman artisans created a form of nanotechnology. They did not call it that. They did not write papers about it. They did not own electron microscopes, and yet somehow, whether by controlled technique, repeated experimentation, or a level of craft intuition we still underestimate, they produced a glass whose optical behavior depends on particles far below the scale visible to the human eye. Was it intentional? That is where the debate becomes fascinating. Some believe the effect may have been a rare but purposeful achievement by elite glassmakers who understood exactly how to manipulate metal-infused glass for dramatic visual impact. Others argue that even if they did not understand the physics the way we do, they clearly understood the outcome. Because a result, this spectacular is not something you casually ignore. Green in one light, red in another. A vessel that seems to contain two realities at once. And once again, the ancient world refuses to stay inside the box we built for it. But if the Lycurgus cup bends light, the final mystery bends something even more concrete. Stone. Travel to places like Sacsayhuaman in Peru, and you will stand before walls made of massive polygonal blocks, fitted together so tightly that even now, a blade can barely pass between them. No mortars, no cement, no visible margin for error. Just stone against stone, locked with astonishing precision. Some of these blocks weigh many tons. Their sides are irregular, angled, and uniquely shaped, yet they fit together as if soft and pressed into place. The walls have endured earthquakes that destroyed later colonial buildings erected nearby. When the ground shook, the modern walls cracked. The oldest stones held. That alone would be impressive. But then you look closer. The contact surfaces are so exact that the construction seems to challenge the limits of hand labor. The joints shift around corners. Faces align across complex geometries. Blocks nest into one another in ways that increase stability instead of reducing it. This was not merely stacking rock. It was engineering seismic resistance through shape. How did they do it? That is where certainty begins to vanish. Traditional explanations speak of hammerstones, abrasion, patient shaping, and immense labor. Those methods can account for part of the story. Perhaps even much of it. But they do not fully remove the mystery, because the scale, consistency, and fit are so extraordinary that even supporters of conventional explanations admit the achievement is staggering. The Inca and their predecessors did not leave us manuals. They left us walls, walls that survive disaster, walls that embarrass assumptions, walls that make modern visitors stare in silence, then reach for the oldest question in history. How? And that question is the thread connecting all 6 technologies we have seen today. Roman concrete that works with the sea instead of surrendering to it. A Greek mechanism that computes the sky. A steel so advanced its method vanished into legend. a blue pigment that outlived jungles and empires, a Roman cup engineered at the scale of particles, and stonework in the Andes so precise that earthquakes still fail to break its logic. 6 technology, 6 reminders, 6 fractures. In the story we tell ourselves about the past, we like to imagine history as a straight climb from ignorance to intelligence, from crude tools to perfect machines, from darkness to light. But the evidence does not always behave that way. Sometimes knowledge appears early, sometimes it disappears. Sometimes a civilization solves a problem so well that later ages can only study the remains and wonder what else was known. That may be the most unsettling possibility of all, because if these are only the technologies that survived, then the real mystery is not what ancient people could do. The real mystery is how much they knew that we no longer do. If the past can shock us this way, imagine what other secrets are waiting to be uncovered. Don't let these mysteries fade into silence. Subscribe to our Explorers and join the journey into the technologies, stories, and civilizations the world tried to forget. And comment below which ancient marvel amazed you the most. Your curiosity keeps history alive.